Hello. The purpose of this video is to continue growing our understanding of algebraic operations with our algebra tiles. So for this session, we are going to explore not addition, but multiplication of binomials and monomials and trinomials using our algebra tiles. So this is what we are going to be looking at, this type of questions. Imagine we have something like this. We have x, and we already agreed that that's a number that we don't know, multiply by something like this, 2x minus 2. Notice that this time, what we are doing is a multiplication. We're not adding. There's no plus or minus sign here. So this indicates multiplication. So we're multiplying a number by another number, except that we don't know what the numbers are. But at this point, that really is irrelevant. So this is how we're going to do this using our Braining Camp application. I'm going to come here and look at something called factors. And then that gives me this frame. Unfortunately, erase my question, but I'll write it again. It was x multiplied by 2x minus 2. And do notice the brackets. This means that this x multiplies everything inside the bracket. So how am I going to set this up? Well, let's think about it like we are setting rectangles. And if you remember the formula for the area of a rectangle, you know it's length times width. So we could think this would be the length and this would be the width of a rectangle. And when we find the product of this length times width, we're actually finding an area of a rectangle. So we're going to think of these with the tiles, and later we're going to use something called an area model, which is the same idea. So let's begin with our X tile that represents the length. And what I'm going to do this time is I'm going to put it on this frame. So that is the length of X, whatever that number is. It's again, it doesn't matter. And then the width is going to be the second factor, which is 2x minus 2. Well, I need 2 of the x, so I'm going to bring 1 here, and then I'm going to rotate it, and I'm going to copy it afterwards. So I need 2 of them. So I'm going to place these this way. So if you begin to notice, we are kind of suggesting an area of a rectangle here. And then I need minus 2. So I'm going to bring the minus 1 here, and then I'm going to copy it. And that now represents what we call the area model. I have x as a factor here. And actually, maybe my eye will allow me to see that. Take a look here. The program is smart enough to give me what I just wrote. Okay, so now let's perform this multiplication. We kind of already had seen this in the first video when we multiply x by itself. In this case, both are being positive, I get the number squared, x squared. So that would be the first part of the area. I need to fill these rest. I can see here that what I need is another one of these because I'm multiplying these by this one, right? So I'm using these tiles to help me see this area. So now I have, and the way I realize that is I'm multiplying this x by each of these two. Now I need to multiply these x by the negative 1. So basically what I'm saying is I need negative 1 times this tile. So let's look at the signs. If I multiply a positive by a negative, my answer will be negative. And x multiplied by 1, a number multiplied by 1 gives me the same number. So the tile I'm looking for is this one because of the multiplication signs and the values. And then I'm just going to copy it because I can see that I need 2 of them. And take a look at this. That is my area model. This is the expansion of this expression, the product, if we want to look at it that way. So this is the area as well. 2x squared minus 2x. So that is the first example of how we multiply, in this case, a monomial. Monomial means we only have one term. There's no pluses or minuses, and this is now a binomial. Before we talk about trinomials, because they had three terms, this has two is a binomial, this only has one is a monomial, and then we know the area is what we wrote, 2x squared minus 2x. Very good. I hope this was friendly enough, and I want you to see how we framed it. Now we're going to move on to another example. So I'm going to erase these. I'm going to leave my frame, and this time we're going to do something like this. We're going to do 3x and see if you can anticipate what is going to happen multiplied by x plus 1. Okay, so now I'm going to set up my frame. This would be my length. This would be my width. So let's start here. I need 3 of these. Let's see if I have room here. I have 1, 2, 3. And let me place them. Let's see if I have enough length here. I sort of do. Okay, so that is my 3x. And now I need the width, which would be x plus 1. Let me see if I can move this. I cannot really move this, so it will come on top of it. I'll write it elsewhere. So here we go. I need x plus 1. I need one of these. But of course, the way I set it up here is rotated. So that is x. And then I need a 1, which will be here. Yes? Very good. So here is my area model. I'm going to rewrite this out of the way. I'm going to write it here for us to see. So I had 3x multiply by x plus 1. Good. So this is my model. Now my rectangle looks a bit different, but I can see that I have to fill these areas. And just like we did before, we can think like row by row. We're going to make this multiplication. So let's say the first row would be x. I have here my 3x and my x plus 1. X multiplied by x that we know is x squared. And now an x multiplied by 1. So think about it. A number multiplied by 1 gives us the same number. So here it is. So I'm beginning to fill my rectangle. I can see that I'm going to have these at least 2 more times. Let's see if I can use my manipulative here and just copy it 2 times and move it so that I can fill my rectangle. Here it is. And I'm able to move it like this. And take a look at my area. I covered the whole area that was highlighted. And now I have my answer, which is, just by reading this, 3x squared plus 3x, which is what we have right here. So we can think of the length being 3x, the width being x plus 1, and then the area being this expression 3x squared plus 3x. Excellent. Good. Okay, we're going to do one more example of these because this is something new. And this time we will involve some negative numbers to give you a better idea of what is possible and what happens in this case. So let's imagine that now we want to multiply negative 2x by negative x minus 3. So there's a lot of negative numbers here, and we're going to see how we deal with them. Excellent. So now let's set up our model again. Now we know the length and the width. And by the way, of course, we could set this the other way around. Length or width really doesn't matter. We could think we can rotate our rectangle. We usually put the first term along here, but we could as well just put it here. So we're going to stick with what we've been doing. So I need negative 2x. Oh, I have negative 1x here. And I need another one, don't I? So why don't I bring it from here? So that's my negative 2x. And I can immediately have it here written by the program. So that's my, say, length. And now here I would need negative x, and minus 3. So I have my negative x tile. I'm going to rotate it. There's my negative x tile. Rotate it. And then I need negative 3, which is this tile repeated 3 times. So I needed 2, and one more time, 3. Okay. So here is now my my rectangle. And again, the program kind of suggests the rectangle. If you notice, it doesn't matter that the numbers are negative. We're modeling based on the tiles. So that makes it very friendly. Now let's take a look at what's going to be making the area for this rectangle. Okay, so the area for the rectangle will be made by multiplying the first row and then the second row. The first row, well, we have the number multiplied by itself, except the number is negative. So when we multiply a negative times a negative, the answer is going to be positive. So negative x times negative x is going to be positive x squared. And then I'm going to multiply the negative x times negative 1. And negative times negative again gives me a positive. X times y1 is the positive x tile here. And then I need it 2 more times. So I'm going to fill this row of the rectangle. And as I'm filling in, Braining Camp is giving me this answer. But I know I still have a little bit more to go because this is past the rectangle. So I need to basically do this again. We can see that, right? So I'm going to take this portion, I'm going to copy it, and then I'm going to move it just down here. And there is my final model. And if we read it, we can see that it is 2x squared, and then I have 6x. Actually, we can see the numbers underneath, but let's write it here, and that's our example now. That is positive 2x squared because the signs were both negative, and positive 6x, which is what we saw here. And just like before, we can talk about, you'll see another methodology called foiling, distributed property. I like this one, and I hope you find it very friendly because we can see how we're building the rectangle. And we can also replicate this idea just without the tiles. So I'm going to do something a bit different. This time, we are going to do an expression like this. And I don't have tiles for some of what I'm going to get. So I will not use the tiles, but I hope you follow what we've been trying to do. So this example, it will involve multiplying a monomial, x, this time by a trinomial. So I'm going to have multiply by x squared plus 2x plus 1. Beautiful. I don't have tiles for, I do have the tiles, but what I do notice is that when I multiply x times itself, I get x squared. But if I multiply x times x squared, let's make a little note here. If I multiply x by x squared, that means that I'll be multiplying x by itself 3 times, which would give me something like this, because x squared is x multiplied by itself. So this is equivalent to x multiplied by itself 3 times, or x cubed. And my tiles only go to x squared. Basically, I would need a 3D shape. I would need a cube to be able to do this. So what I'm going to do is not use the tiles, but I use the same method. I'm going to use these as my area model. And I'm going to still think of this as the length and this as the width. It is the same idea, and I hope you can see it very easily. So my length is x. So I'm just going to literally write it here. And the width is x squared plus 2x plus 1. So I'm going to write it here as well. X squared plus 2x plus 1. And I have a rectangle-ish. I know my my lines are not perfect, but I hope you can forgive me for that. And we're going to find the area, this area of a rectangle. And we're going to do it the same way we did the multiplication before. We're going to go row by row. And in this case, we only have one row anyway. So let's begin with this. When I multiply x by x squared, we already established that this is x cubed. I just don't have a tile, but it doesn't matter. So this is x cubed. And then this is a positive number multiplied by a positive number is going to produce me a positive number. And then x times multiply by 2x. Let's see if you can remember what that would do. So I would have one of these tiles multiplied by two of them. So I would have 2x squared, just like we did before. And finally, I would multiply positive by positive to get a number times 1, which I know is a number, the same number. And that is the answer to our area model. So when we look at what we just did, we can identify these as an area, which is what we call the expansion of this question. And that is how we use the area model without the tiles. Now that we've understood how the tiles work, and I can see here this multiplication, and I can just write it here as my final answer, as my expansion, as the area that we just found. And that is it for this example. I hope you followed it. Now we're kind of graduated from the tiles. The only reason we cannot use the tiles is because this x cube, that means we would have to have literally a cube, which we cannot do on the screen, at least not in the way we have this displayed. We're going to do one more example for you to look at and using this area model. So I'm going to clear this example and I'm going to write the next one. And the next one is somewhat similar, is also a monomial by a trinomial, which is the expectation that we have for these cores. So this time we'll have negative 2x, and we multiply it by 3x squared minus x plus 5. Good. So I'm going to set up my area model, my length and my width, and I'm going to find the area of this rectangle. So here is my length, negative 2x, and here goes the width, 3x squared minus x plus 5. Sorry about my plus, it's not very nice, but you know what I'm trying to do. Good. And here is my rectangle, right? My rectangle. Sometimes I can break it down into 3 parts. I think in this case is good enough like this. So let's do this multiplication. Again, I'm going to go multiplying this one row by row. So negative 2, let's look at the numbers, and we call these numbers coefficients, the numbers that are in an expression that is the number. The opposite, not the opposite, but this term, as we know, is a variable. So this is the coefficient, and this is our variable. So the coefficient here is negative 2. The coefficient here is 3. And if we had tiles, we would arrive at 6 of these. So it would be negative 2 times 3, which is negative 6, because I'm multiplying a positive and a negative. And x multiplied by x squared, we established that it was x cubed in our previous question. And then we do the same multiplication. Negative times a negative is going to be a positive. And then we have 2x times x, that would be 2x squared. Multiplying, remember this, we're not adding. And finally, a negative times a positive is a negative, and negative 2 times 5, negative 2x times 5 is be 10 times x. And that is the response or the simplification or the expansion rather for this expression. Negative 6x cubed plus 2x squared minus 10x. Well, thanks for watching. Now you are going to go and do some examples.